All right, so today's lesson, 6.2, we're talking about probability in this entire chapter. And there's actually two approaches to probability we're going to talk about today. Two approaches to probability. So I'm going to ask you guys, and I'm going to have you guys show hands. How do you guys remember learning probability with like a bag of marbles? And you have like red marbles, green marbles, blue marbles. Okay, you guys remember that? Okay, me too. So it was like you have a bag of 10 marbles and 6 of them are blue. What's the probability that if you randomly pick a marble, you get a blue marble? Well, it'll be 6 out of 10, right? So 60%. All right, so that is what we call the classical approach to probability. All right, that's called the classical approach. And it's basically the ratio of favorable outcomes. In this case, we thought blue marbles, right? So 6 of them out of the total number of marbles, 10. So 6 out of 10 giving us 60%. Okay. So yeah, this is a classical approach. Now, the thing though with classical approach is it's limited. And how it's limited is that you can only use it if the outcomes are equally likely. That's why I underlined this. All right, only when the outcomes are all equally likely to happen, then you can use the classical approach. Okay, so for example, flipping a coin, rolling a die, those all have equally favored outcomes. So we can use the classical approach. Okay, so let's try this. Let's go, Jonathan. Jonathan, can you read this one out for us? Jonathan?
Oh, sorry, I was muted.
Okay, no worries. Can you read this problem out for us?
On some football teams, the honor of calling the toss at the beginning of the football game is determined by random selection. Suppose this week, a member of the 11-player offensive team will be selected to call the toss. There are 5 interior linemen on the offensive team. If event L is defined as the event that an interior lineman is selected to call the toss, what is probability of L?
All right, thank you, Jonathan. So we'll try it, Jonathan. We want to find the probability that an interior lineman is selected. So how many interior linemen do we have?
5.
Okay, and then how many total linemen, I guess, do we have?
11.
Or on the offensive team, yeah. So 11. So what's the probability?
5 out of 11.
Yeah, good. That's it. Okay, so 5 out of 11. Decimal form is preferred, so 0.4545, or you can put in percent, 45% works too. Yeah, all right, that is the classical approach. Perfect. Okay, now let's try a different scenario. This time, all right, let's go archery. So raise your hand if you have ever done archery before. Whoa, actually, well, that is a lot of you. What are you guys doing in your free time? Oh my goodness.
We did it at when we went to Wonder Valley, I think we all did archery.
You guys
in like middle school.
Wonder Valley too? Is it still 6th grade?
Yeah.
And then is it still Simi Valley for 7th grade?
No, we go to Catalina for 7th grade, and then now I think it's Pali Mountain for 8th grade.
Oh, okay. It used to be, yeah, Catalina Island. We call it Simi Valley.
Okay.
Yeah, it's still Catalina for 7th grade. And then we did Astro Camp for 8th grade. So what do you guys do now for 8th grade?
We go to Pali Mountain. I think Astro Camp, the last grade that went was the 2018 class.
Oh,
I think.
Got it. Got it. Oh, cool. But you guys still go to Wonder Valley? That's amazing. Did you milk the goat?
No.
Cow?
No.
You milk anything?
Well, we rode horses.
Okay. Oh yeah, I rode horses too. Mine was the pooper, and it would just poop all the time. So I was at the very, very end because it was so slow, because it would stop and just like drop a dump. And it was, yeah, kind of fun, but embarrassing. So anyway, that's not what we're trying to find the probability of. All right, Bella, can you read this one for us?
Yeah. Consider an archer shooting arrows at a target. For shots that hit the target, the probability of getting a bullseye should be the ratio of the area of the inner circle to the area of the entire target.
What
Continue.
if? Yeah.
What if a very experienced archer were shooting the arrows? Would the probability of a bullseye still be the same?
Okay, thank you. So, okay, if we wanted to do the classical approach with this problem, we literally would just take the area of the bullseye, divide that by the area of the entire target, assuming we always hit the target. And some of you guys at Wonder Valley probably missed the target, because I know I did. But assuming you hit the target, that would be the classical approach. Area of the bullseye over area of the entire target. Now the question is, does the classical approach work here? Especially if we have a very experienced archer. Like, for example, I don't know if you guys remember like Hunger Games, but like Katniss Everdeen, right? If Katniss Everdeen was shooting at the bullseye, is the probability of her hitting the bullseye the area of the bullseye over the area of the target? No, right? Her probability is probably like 100%, right? The reason why is because the probability of hitting anywhere on the target, it's not all the same, especially if you're aiming for the bullseye and you're really good. The probability of you hitting the middle is a lot higher, right, than hitting anything else on the target. So we should not use the classical approach on this. Okay, so let's say we hired Katniss Everdeen. I don't know. Let's say she's a real. Okay, maybe let's not use Katniss Everdeen since she's a hypothetical question or a fictional character. Let's say, okay, let's say Steph Curry, basketball, right? Steph Curry. He's known for being able to shoot 3-pointers. Am I right? Yeah, he's pretty good. Okay, if we wanted to find the probability that Steph Curry can hit a 3-pointer, what would we need to do if we wanted to find his true probability? Would we have him shoot once and just be like, hey, he made it? 100% chance Steph could hit a 3. No. What would we need to do?
Wait, are you asking me?
Sure.
Oh,
I wasn't, but now I am.
I said Seth, but you said Steph.
I said Steph, like Steph Curry, but hey,
Oh,
go for it.
hey, can you repeat that?
Yeah. So like if I wanted to find the like Steph Curry's probability of hitting a 3-pointer,
Mm-hmm.
how would I do that? Like how would I be able to figure that out? Because I can't just have him shoot one and just be like, oh yeah, he made it. So 100% chance every single time now Steph Curry will hit a 3-pointer. What would we need to do or observe?
So like maybe like 10 throws.
Okay, so why 10?
See.
Yeah, why 10 and not 1?
Because it's like with 1, it doesn't mean you're gonna be consistent every time, and 10 you could see like basically how consistent you are.
Mm-hmm. And then okay, what's better, 10 or 100?
100.
Okay, what's better, 100 or 1,000?
1,000.
Yeah. Well, assuming that he doesn't it's not consecutive, he's not getting tired. Okay, well,
Yeah.
we'll put that out there. Yeah. So basically, I'm just trying to show you guys that you naturally are intuitively doing the relative frequency approach, which is our second approach to probability. Okay. So what you're kind of thinking of is finding the probability by having a lot of trials, right? Like you said, Seth, 10 or 100 or 1,000, right? In a very, very long series of trials, see how many times your event occurs. In this case, making the 3-point shot. So out of 10, maybe he makes 7. So then we say, okay, 7 out of 10, 70%. But maybe out of 100, he makes 75. Then we're like, okay, 75%. All right. So the more trials you have, right, the more accurate you can be. So this is known as the relative frequency approach. And remember, relative frequency is just a fancy way of saying percent, right? It's just a fancy way of saying percent. All right. So this approach is actually an approach by trial, by actually having the person shoot arrows a bunch of times or shoot 3-pointers a bunch of times. All right. But you guys naturally, intuitively, I think, know this approach. You just now have a title for it. Okay. All right. So because of distance learning, typically I would have you guys in my classroom. I would have a bunch of decks of cards and I would have you guys draw cards. But unfortunately, we're not able to do that. So we're just going to jump to kind of the moral of the story or moral of the activity, which is the longer the number of trials, right? The more trials you have, the closer you would get to the true probability. Okay. The more trials you have, the closer you get to the true probability. So this is like flipping a coin, right? And you're trying to see how many heads. If you only flip like 1 or 2 times, you might get very, sporadic relative frequencies, right? You just happen to flip the coin twice and you got no heads. So you have 0. Or let's say you flipped it twice and you got both heads. Well, you can get 100%. So it's very sporadic when it's a small number of trials. But look at the simulation graph here. They simulated flipping a coin like 1,000 times. And you can see that it goes from being very sporadic to kind of averaging out closer and closer to the true probability of 50% chance of getting heads. All right, so this is the last kind of big thing, which is that this phenomena of the more trials you add, the closer it gets to the true probability. This phenomena is so important that they named it a law. They named it a law in math, in stats. And this is called the law of large numbers. The law of large numbers. And it basically is saying that the more trials you have, the closer your relative frequency gets to the true probability, right? The more trials you have, and I like how the yellow bubble actually says it more so than this top part. The more trials you have, the closer your relative frequency gets to the true probability. All right, any questions about that? Okay, well, hopefully that's kind of intuitive, right? And you guys, again, have that natural instinct of, yeah, if I have 10 tries, great, but 100 is better. Oh, but 1,000 is even better. All right, and that's the law of large numbers that you guys naturally have experienced in the real world. Okay, and that is it. All right, so that is our lesson today. So the three things you want to take away from today's lesson. Number 1, the classical approach to probability. Second, the relative frequency approach to probability, which goes along with the law of large numbers is the third thing. So classical approach, relative frequency approach, law of large numbers. Any questions or clarifications on those 3 things?